Hello, Fuzzy. Welcome. I'm doing pretty good today. How are you? Morning, Top Wolf. Morning, Pig. Good morning, Cade. Good morning, Uchu. Good morning, Brandon. Good morning, CS202 student. Good morning, Kane. Turbo, welcome. Chef, good morning. Giovanni, good morning. Welcome. I think that's pretty good. Yang, good morning. Santos G-Man, welcome, welcome. All right, so first off, I have the stream pulled up on my phone, so if we get any people telling me they want followers, I should be able to ban them through that. Thank you, whoever recommended that last time. I guess the term is administrative. We've got a few administrative things to talk about. The third assignment is up. As always, there is a due date there set, and it may change depending on how things go. All right. It is the inheritance assignment. Now, guess what? I said this at the beginning of the semester. I also said this, I think, last week too. I'm going to be sure to review all of the assignments. In this third assignment, I reviewed it, and truth is, we're just not ready to do that one yet. So this third assignment you're doing is different from the other sections, all right? So I'm warning you of that. It's different than the other sections. So if you are talking to other people or getting help from other TAs, which I don't recommend you do, please do not talk about it. Well, you could, but no one's going to know what you're talking about. You know what I mean? So, it's a different one. It's one that I made, and it's my favorite way to teach inheritance. The assignment was created probably 30 minutes ago. Yeah, it was just uploaded this morning. We haven't talked enough about inheritance yet to really get started on it. So there was nothing this weekend. I'm sure after these first two assignments, some of you could use a break. That second assignment was a lot easier than the first one, but a lot of us still struggled with it. I don't think you got really any good practice declaring the objects in main, since that skeleton code was provided for you. So this third assignment here, I assure you after today, you should be able to do it. But you're going to make everything. And if you want to test it, you're going to have to make your own main file. So for those of you who are having trouble understanding the concept of objects, that's your chance to practice, okay? So take a look at it when you want. I have it set due for Sunday for now. We'll just see how far we get today. Tell me if I pronounce this wrong. I'm going to say Lalo. C++, the rand function we use is pseudo-random, meaning that it comes with a seed. You can't just ask your processor to give you a random number. It doesn't know how to do that. There's some program that does it, and it has to start from somewhere. So kind of like your Minecraft servers, you can put in a seed. Minecraft randomly generates maps, right? And how is it random? Well, it all starts from a seed. So rand always starts from the same seed. I think it's probably 0. So none of the assignments were seeded. Some of you did seed it. I don't know why you did that. I don't think it told you to do that. But if you didn't seed it, the same random sequence would happen every time. So not very random, per se. If you want to make things truly random, truly, in finger quotes, you're gonna seed that rand function with probably the time in seconds. And that will give you kind of a different output every time. So I hope that answered the question. Yeah, that would have messed it up. That definitely would have messed it up. All right, so we're going to continue on with inheritance. We only kind of briefly talked about that stuff last time. So this is really the only thing that we talked about. Which was this stuff. And to be fair, Layla, we talked about that quite a few times. That question was asked quite a few times last week. So I'm sorry that you messed it up, but we did talk about that plenty of times. Now with inheritance, as we discussed, it's always used with classes. In composition, I guess also it comes with classes. All right, composition is just kind of a term we use. I wouldn't necessarily call it an important concept. We just need to understand the difference between what inheritance is and what composition is, in which things can have other things, though they're not directly related. So remember that composition we consider to be has a relationship in which one class will include another class. A deck has a car has an engine. Inheritance, of course, is different. This is the main concept that we focus on. And that is an is-a relationship. And since one's class is based off of another class. So we did talk about this. My favorite example is a cat is a mammal, but it is a one-way relationship. Since a mammal is not a cat, but a cat is a mammal. So when it comes to coding in C++, there's going to be a base class and a derived class. And this is the relationship here. And the most important thing to always remember is derived classes have all of the members in the base class. So we kind of had this little example here. Yeah, there's no chat delay. I restarted my computer. I closed Chrome. Hopefully we're going to have a good day here. So say we have some class mammal. And I'm not really going to put many variables in here. I'm just going to say things like little comments like it says it has live birth, right? We all know that. I think they have warm blood. And that's pretty much the extent of my biology knowledge. So then a class cat, and I'll take notes on this in just a moment, but if we want to inherit from it, we have to use this colon here. Once again, we'll get into this in just a moment. I just want to give you this example here. So this class cat is going to inherit from mammal. So this is kind of the syntax for that. And so this cat might have whiskers in it. This cat also might have some eyes. I don't know if there's any mammals that don't have eyes. Maybe they are, maybe they aren't. I think mammals all breathe air, right? That's another thing. Whales breathe air. Dolphins breathe air. And fur, you know, that's something. And so we always need to remember that cats also give live birth, have warm blood, and breathe air. All right? So, cats are mammals. Mammals are not cats, all right? So we're going to do some fun examples of this today. As always, I would like to just pull up my notes here. Should have done that before class, but sometimes I get a little mixed up here. Okay, so Fuzzy, you have a great question. Inheriting a class is useful for if you don't want to rewrite things over and over again. Giovanni asked, does the colon have a special name? I'm going to say no, it's just a colon. Now, I know some of you are gamers. And for those of you who are not gamers, I'm really sorry. Because I'm about to talk about a gamer example. It's my favorite way to teach inheritance, and your assignment is based off of a combat game. All right, so I know some of you play some games. I'm going to give you some examples. League of Legends, Overwatch, World of Warcraft, Super Smash Brothers. All right, these games, they all have playable characters, and every character has, say, same amount of things. So I'm going to use this here just in the notes. We're going to have a gaming example here. And this is an answer to Fuzzy's question. Consider a playable character. Now this is going to be very basic. Character. It's going to be very basic example. Now playable characters sometimes have things like health points. They sometimes have kind of stat integers, right? What might those be? I don't know. Strength, skill, or dexterity, maybe defense, stuff like this. They come with, like, say, movement speed and stuff like that. And then they all kind of do similar things, right? Can say attack, block, run, etc. So in this gaming example, you're going to have a base class player. In which, in the base class, you're going to set all these things up. You're going to say, hey, every player has some health points. Every player has a strength, skill, and defense level. And all these players can attack, they can block, and they can run. We're basically hiding the things that are shared by all players. So that's kind of up here in the base class. And then your derived classes come out. So for those of you, once again, who are not gamers, I'm sorry, but tanky, maybe a tank class. These guys have high defense, maybe slow move speed, because they're wearing so much armor. You might have, I don't know, you League of Legends people call it maybe a damage class, right? Which they're probably going to have a high damage, and perhaps a low defense. And honestly, the list just kind of goes on, all right? So do you understand that the derived classes, they only differ from this base class player only very little bit. And so the derived classes will be responsible for communicating those differences, but we're not going to have to rewrite all of this code, right? All of this code is saved up here in the base class. Well, the base class, we're going to get to this later on when we start talking about virtuals, but it can be made so that a base class player cannot be defined. You can make it so the base class player cannot be created. It's almost just like a little blueprint that's hiding up in the sky somewhere. And everything will just be based off of that. Synthos, that's exactly right. It is a subclass that inherits all of the traits from the main class. And derived classes can have more derived classes. So let's kind of talk about that. Let me just go on the notes here so I can stay in order. Yeah, so male, it is like a template. All players have health, but not all players have the same speed. And to further your point, not all players may have the same health. So what we do know is that players have a speed variable and they have a health variable. But in the derived classes, it will change. The base class doesn't have access to the derived class. That's 100% correct. Remember, a player is not a tank. A tank is a player. So this base class cannot access the things that we put in the derived class. It's a one-way. It's a one-way relationship. So before we start talking about all those details and kind of put them in notes, let's just talk about the member access specifiers and the way that we inherit, okay? So we know what these things are. We've seen them before, and I've mentioned them previously. So we have public and private. Does anyone remember what the third one is that I didn't really talk about? Does anyone remember what the third one was? Protect. Yeah, protected. Public, private, protected. That's our third one. All right. Now, I'm going to redefine these as just kind of an inheritance concept. All right. So when we're talking about member access specifiers, there's two ways to use MAS. Two ways to use the MAS. The first way is to alter the access of members, right? Controls the access of members. All right, and the second way to use an MAS is to define the inheritance method, all right? So there's two ways we can use it. One, we're controlling the access of members, right? In this example, we say int x is private. In this example, we will say something like tank class inherits privately from player class. All right, so I'll talk about these things in just a moment. And these are the two ways we can use the member access specifiers, the MAS. So just to review, we're talking about one here, control the access of members. We all know what public and private is. Can anyone take a guess on what protected is? Of course, public is accessible to everybody. Sorry if I spelled that wrong. You know who I am. I am a mirror. Someone help me out. I don't have Chrome open, so you can help me if you want. Just don't judge me for my terrible spelling skills. I know I spelled that wrong. I think it's two S's, right? I think it's... It doesn't look right. X... Yeah. You guys are not helping. Some of you help. That's good, right? I think so. This is accessible to only the class. And let's see what we got here. You can have access through certain functions, can only access a certain way. Is protected only accessible through the inherited classes. Klaus, you are the closest. You are the closest. Protected is like a special kind of private in that it is accessible to the class and the derived class. Okay? So in the assignment, you'll see some things are protected. Protected things can be accessed by the derived class. Protected things can be accessed by the derived class. Private things, though, cannot be accessed by the derived class. So this is kind of a hard concept to understand. So before I move on to the second thing, I like to call this thing super private. All right. Let's define super private. Now, this is a Mr. P term, okay? This is not a Google term. But I like to have an identifier for what we're trying to talk about. So super private is when a base class or when a derived class has a member variable that is private in the base class. So this is kind of hard to wrap your head around. So tell me, tell me if I'm making any sense. And we should really get coding today. I think that's probably a good idea. So hopefully we can get something going on here. Now, super private is not different from private in a sense, but we want to kind of have a way to identify or differentiate things that are private and things that are super private in our class. All right, so this is what I'm talking about. So this is going to be our example one today. Yes. Okay. So, of course, I'm going to grab my favorite things. And for now, we're just going to do kind of some basic templates here. All right, just some basic templates. I'm not going to give anything a name yet. We're just going to have, say, a class base and a class derived. And we'll talk about inheriting things in just a moment. But what we're going to say here is that we're going to have some private variables. Once again, say like int x. Now this derived class has an x. All right, that's kind of what I'm asking about. Top Wolf, I will get to that in a little bit. Go ahead and hang on to your constructors and destructors because that will come very shortly. So what I'm talking about here is this derived class has an x, but it does not have access to it. All right, this is what I'm going to call super private. In derived, X is super private. This is what I'm talking about, okay? Yeah, Chef, you're right. That's right. And I just want to hold on to that one moment. I'll put that there for you, just because you're right. But we're going to come back and change it in just a moment. All right? This is the basic way to do it. But let's continue on talking about this. In derived, meaning in this class, in derived, X is super private, all right? It has an X. It doesn't have the ability to access it. So it's kind of hard to think about. It's kind of hard to think about. I don't know. It's kind of like we have a brain in our head, but we don't have access to some of it. Is that understandable? Then you might have something that's protected. Okay. That might be int y. And then, of course, you have something that's maybe public, and that might be int z. All right, so the derived class has access to this y and to this z, but it does not have access to this x. So now that we've defined super private, let's talk about this second thing here, in which we can use an MAS to define or specify, the inheritance method. All right? So this is just an example. So we can actually make it so that our derived class inherits differently, or in kind of different forms. All right? Let me kind of put some lines here. Love having the lines. So if we inherit publicly, and here's kind of what it looks like. So we can either inherit publicly, privately, or protected. I have a question here. Does the class call have to be first base and then derived, or could you call them something else? No, you can name them something else. We'll have an example of that in a little bit. For now, we're just going to call it like this, just for fun. Maybe I'll stick with Clang Tidy here or something. I'm sure Clang Tidy would be mad at me. When you say access, do you mean directly modifiable? Yes, that is what I'm saying. So let's go ahead and do our example here. So first, we're talking about inheriting publicly. All right. So in fact, I'm gonna put this MAS here. I'm gonna say I'm gonna inherit publicly from base. And then let's pretend like I have, I don't know, a constructor here that I'll use for fun. And in this, I cannot access X or modify X. But I do have access to Y because Y is protected. And I do have access to Z because Z is also public. Does that answer your question? X, I guarantee you I will get a compiler error the moment I say this here. We can take this onto Bobby if my VS Code will save. Whoa. Are you guys, yeah, I know. Are you guys here? I think it's MOBA or something. I'm going to have to... Who is it? Someone in the Discord keeps telling me to do something else. I might just have to switch editors and from using Bobby. Maybe I'll do a local... IDE or something. So I did see some questions. Okay, so I'll get to those in just a moment. But back to what I was talking about to answer Pig's question. Notice that base X. Notice how it's referring to base X as this is where X exists. It says this belongs to the base class. It says it's private within this context. It's private. So I actually don't have any issues. Now let me kind of go up here. Klaus asks, would Y be public in the derived class? We'll get to that, Klaus. Give me one sec. When local make it works? I don't think so. There's something that's going on with MOBA. When I click on MOBA and VS Code together, I think that's what it is. Chrome hogs my RAM, and then as soon as I've got MOBA and VS Code working together, it just is not working like it used to. I think if I had it all in an IDE, it would probably be much smoother. So, Pig, hopefully I answered your question about this. I can't modify this, but I can modify Z and Y. Now, we'll talk about these inheriting methods, all right? So, if we specify it to be public, there's three things that happen. The first thing that happens is public members in the base class remain public, and this is to answer your question, Klaus. Public members in the base class remain public in the derived class. Protected members in the base class remain protected in the derived class. Now, what happens to the private members? Can anyone tell me? I hinted at this already. What happens to the private members? What happens to them? What do they become? What is this special thing that I'm talking about? What do they become? Now I know there's a chat delay, all right? I'm sorry. Let's just stay strong. Let's just stay strong. They become super private, right? That's exactly what happens. Private members in the base class become super private in the derived class. All right, that's what I'm talking about. That's why I like this term. That's why I use the Mr. P term here. That's because I don't want to say private members become private in the derived class, because that's not true. What happens if I did this? What happens if I come up here and I said, hey, you know what? My derived class has a new variable. This is my int a. This is a private variable in the derived class. X is not a private variable in the derived class. This is super private, right? This belongs to the base class. It's up here. So we need to have a way to tell the difference between this guy, the private int a from the derived class, and this guy, the super private guy from the base class. All right. So if you have any confusions on that, please let me know. But that's how I call it. All right. That's what I'll ask you on tests, and we're also going to start having small little quizzes. They're just open for the whole time that the assignment is open. And I'm just going to ask you 3 questions about what we talked about. You can answer all of them by referring to the notes. They're not timed. You can retake them. All right. It's not really a quiz. It's just me kind of giving you some study material for the test and things like that. All right. So I'll ask you about that. And I'll get to that when we get to the assignment. Just remember this, though. Private members in our base class become super private in the derived class. Now we're going to talk about protected. All right. If we do a protected inheritance, it is a lot to wrap your head around, but for now we're just doing the notes. We're just doing the notes right now so you have something to reference. And then we'll kind of try to tie up some loose ends here with some examples later on. If we're going to inherit protected, all right, it's kind of the same stuff. Now guess what? In every single inheritance, private members in the base class are super private in the derived class. That happens every single time. It will never not happen that way. All right. Private members in the base class are always super private in the derived class. Now, public members, these become protected in the derived class. Turtle asks, what can access the super private variable? Can anyone answer that? Does anyone have any ideas? That's a great question. That's a great question. What can access the super private variable? Someone's had to have some ideas here. And similarly for our protected members, they will actually remain public. All right, so those are the only differences there. Klaus says only the base, Syntho says only the base. That's correct. So check this out. You guys ready for some fun? What if I have up here protected void set x int x1? So this, let's not even do it this way. Let's just say x equals x1 here. This is a protected member. And this base class, this is the base class. So the base class has access here. Right? Base class has access to x. So only the base class can access that value. So if I'm down here and I say, hey, set x 0, this will work. Why? Because I'm using a protected function from the base class. Does that answer your question, Turtle? Only the base class can access these super private members. Only the base class can. If you want to access that, you're going to need something like a setter and a getter. And you're going to make it say protected. So that down here in the derived class, I can mess with it. To say, hey, I'm going to use the things that the base class provided for me to access this super private member, all right? So yeah, once again, to answer that question, only the base class can access it. Hopefully I didn't lose you here. Now, private inheritance is the easiest one, all right? Public members become private in the derived class. Protected members become private. In the derived class, and private members become super private in the derived class. All right? So these are our inheritance methods, all right? So now I ask, how do we specify an MAS? Well, that syntax is here. Yeah, no, Turtle, everyone is delayed. Everyone's delayed. I'll even put it here. I'll work on it. I'll work on it, I promise. I'll even give you a sad face to let you know how I'm feeling about it. Now, the syntax for that is going to be the class, base class. The MAS goes here. And the derived class, whatever that is. No, I messed that up. I messed that up. Don't listen to me. Don't listen to me. Goes like that, all right? I get mixed up here, okay? Class derived class, and then the member access specifier base class. Now, I showed you already that we can do kind of just a default. What if the MAS is not specified? Well, then it defaults to private. So does that make sense to you guys? If I come in here and I say, hey, I'm not going to put anything here, it's basically like saying that this is private. There's always a default. There's always a default. All right, if I don't put anything here, it's going to be private. And what happens in private? Well, Z becomes private in the derived class. Y becomes private in the derived class. And X becomes super private in the derived class. You're all going to get to practice with this. So it's a little bit, I know it's a little bit scary right now. Now, usually I do public inheritance. The truth is, there's never like a right way to pick these. It all depends on how you define your class. It all depends how you define your class. If you make everything public in the base class, your inheritance method might be protected or public. There's kind of a bunch of different ways to mix and match these. There's a bunch of different ways to mix and match. Mix and match. Number one here, what access are just the actual members, and then number two, what kind of access is the inheritance? All right. So you have a bunch of different ways to do this. There's never really a correct way. My favorite is to always inherit publicly. I'll always usually do that, but that's because I design my classes that way. All right. So now we're about to get into some examples here. Man, we're moving along here. All right. We're moving along. We're almost done with our notes. And then we're going to have plenty of time to code here. So there's only a few more things we need to talk about. All right. There's only a few more things we need to talk about. Now, the first thing we need to talk about is constructors and destructors. Constructors and destructors, all right? Constructors and destructors. So first we're going to talk about constructors and inheritance. So I'm going to tell you this. Derived classes will always call at least 2 constructors. Derived classes will always call at least 2 constructors. So this is kind of the question I go back to. In the example, say mammal and a cat. And this might be kind of a silly question, but is the cat a cat before it's a mammal, or is the cat a mammal before it's a cat? Does that, let me put it here, and you guys can just give me a 1 or a 2. Is a cat before it's a mammal? Or is the cat a mammal before it's a cat, right? Yeah, let's not talk about that chicken egg stuff because I have some hot takes on that, but we're going to talk about cats and mammals. And Pig and Chef and Yang and Pig and Klaus and Oyman and CS202 student, you're all right. It's a mammal before it's a cat. So what constructor is called first? That's kind of the idea. Number 2. And so it's going to be its base class constructor and the derived class constructor. All right, and there may be more, all right? And I'll talk about that in a little bit. Number 2. So, the base class constructor is always called first. All right? It's always called first. The mammal constructor comes first. And then the cat constructor. All right? Now, here's kind of a fun little thing. Is there a way we can specify the constructor? Meaning, base class can have more than one constructor, sorry. Can we pick one? So now let's get into kind of the example part of this. I'm going to start kind of working on something else here. So let me get some CPP files going. And I have to remember what kind of example I usually like to do for this one. So I'll just reference my last class stuff. Let's see what I was talking about. Now I see there's something in there talking about chicken egg stuff. Yeah. Giovanni. Yeah, we don't, Giovanni. You're right. I always talk about shapes, huh? I always like to do shapes. I don't know if I like that one. Maybe I can pick a different one. Why am I always doing shapes? Shapes are a good one, right? But shapes are actually better to discuss for virtuals. I am always doing shapes. Let's do a vehicle instead. All right. Let's do a vehicle instead. I like that. Teaching. Where are we at? Getting all mixed up here. All right, here we go. So let me come in here and grab my favorite stuff. That's good enough. Did I just... Oh, I guess I copied it. That's fine. So let's see here. CS202 student, you are so ahead of me, but yes, you're 100% correct. That's a great question. You're so ahead of me. So I'll come back to this. Let's go ahead and talk about the destructor. And yes, it's called in reverse. I'm so glad that you guys are thinking about this. Inheritance. All right. Derived classes. I'm kind of referencing the same stuff up here. We'll always call at least 2 destructors. All right. Now, it's kind of the idea that we said that the derived class doesn't have access to the base. The base class doesn't have access to the derived class variables. So the derived class variables should be destroyed before the base class is destroyed. Otherwise, it's kind of, you can't fix it from there. All right. So the derived class constructor is called first, and then the base class constructor is called next. Or not constructor, I'm sorry, the destructor. My words always get mixed up here. Destructor. All right. So in this case, the derived class constructor is always called first. So it kind of makes a pyramid. This is a Mr. P example here. It makes like a little pyramid. And so my little pyramid is like this. The base constructor comes first. And then say the derived constructor. And then say maybe the derived 2 constructor. Now I'm kind of getting ahead of myself here. Someone asked previously if there can be multiple inheritances, and yes, there can be, so I'll get into that in a moment. But when, lives its life here, and then the derived 2 destructor is called, and then the derived destructor is called, and then the base destructor is called. So you understand what I'm saying here? It's like a little pyramid. This comes first, second, and then third, and then this one comes first, second, and third. Yeah, mammal, cat, tabby cat. In my example, I would say mammal, cat, house cat, calico, something like that, right? Pig, you're 100% correct. You're completely correct there. All right, so hopefully that answers your question, CS202 student. This is how it works. It's like a pyramid, and you read it top down. No. Only pyramids in computer science are good. In computer science, all right? So we talked about that. So now we're going to talk about this whole specifying thing. So we're going to get back into my example here, in which we say have a class vehicle. Let's say we also have a class engine. Just something like this. It's going to be a very simple example. All right, we're going to try to keep this as simple as possible. So there's plenty of different engines. Excuse me. We're going to have plenty of different engines. All right, and then we're also going to have a few different cars. Vehicles, rather. We'll call them vehicles. Jeez. All right, we're going to have engines and we're going to have vehicles. Now, Clang Tidy will probably yell at me, so we'll fix that. Now, all engines, we're just going to say in this kind of simple example that they have, say, some horsepower. And then what do they have? Like cylinders? Now, I'm not a gearhead myself, so feel free to correct me as long as it's within bounds, but we're going to have, say, a horsepower. And there might be some amount of cylinders. Oh my gosh. I think I got it. All right. I really got to hydrate here. I got to clear my throat. And of course, I spill water on myself. Cylinders. Okay. Thanks. I'm nervous, guys. I'm nervous, okay? So, I'm just going to say, maybe this is kind of like how much the engine can pull. Like that's kind of a weight. And let's say this talks about how fast it can go. All right. Now, like I said, I'm not a gearhead, so I'm probably wrong, and I apologize to you. All right. All right. But let's say every engine kind of has these things. Now we're going to say, hey, we've got some constructors here, some basic constructors, in which we're going to initialize these values. All right. We're going to just see out something like, we're going to do some messages like we always do. This is going to be engine default. Default engine created. And then we're going to initialize these values, right? Horsepower is probably 0, and the cylinders equals 0. All right. So that's going to be our default. Now, what do you say we have another constructor? Let's have another constructor here. A parameter constructor that's going to initialize these things just the same, except instead of 0, it's going to come with some stuff. As someone else called it previously, it could be a specialized constructor. See? All right, and we'll just say, hey, this is going to be the HP, and this is going to be the C, and this is going to be engine param. All right, so we've got some kind of basic constructors here for our engine class. What do you say? Seems pretty normal. Now, let's make some derived stuff. What do you say? What do you say we make some derived stuff here? Make a sports engine. Now, I'm not sure. Like I said, I'm probably going to get it wrong. Let's make a kind of a truck engine. And then maybe let's make a passenger engine. You say no? Klaus says, in the derived class, when we make the object, would we include the parameter for the base class to specify it? Yes, Klaus, we're talking about that right now. Yep, we're going to get into that. So, someone help me out here, all right? I'm not even going to give you one. Tell me, if I want this class to be named Sport Engine, how am I going to inherit from it? Let's say I'm going to do a public inheritance. What's the syntax for it? Can anyone tell me? Can anyone tell me? If I want to make a class Sport Engine, what is going to be our syntax? And while I'm waiting for the delay here, I'll just kind of type some stuff out to get ahead of ourselves. Class, public sport, and almost. There you go. Top Wolf and Giovanni. If we combine the power of your answers together, we will get Sport Engine and the engine class. Public, I can't forget about that. How about that? There we go. That's what it looks like. If we're going to have a truck engine, that's going to be a public engine. And then say we're going to have a passenger engine, which is going to be, say, public engine. All right? Now, these all are going to have their own little... I don't know why I keep saying public. I don't know what that is. They're all going to have their own constructor, say default constructor. Now I'm going to ask you a question while I'm doing this. What Klaus asked and what I asked previously, I'm going to kind of pull up the notes here. Is there a way we can specify what constructor we want? Look up here. We've got 2 of them. And we're going to say, hey, I want my sport engine to have a lot of cylinders. It probably has a lot of horsepower too, but maybe not as much horsepower as the truck engine, okay? I don't know. So we're going to say, hey, I want to call this one. I don't want to call that one. I want to call this one. Is there any way we can do that? And I'm going to ask you, do you think this works? Tell me, do you think it works? What goes first? Horsepower? I don't know. Let's say it has 100 horsepower. Let's say it's got like 8 cylinders or something. Do you think that works? Tell me. Do you think that works? Do you think that's fine? Or do you think there's a problem with that? What am I doing? No, I got that right. Engine. Yes or no, I'll even take that. I won't even ask you why you think so. Just say yes or no. I won't even ask you why. I'm not going to ask you to justify your answer. All right, I'm trying to specify my parameter here. I want to say, hey, you know what? This guy's got like 500 horsepower, but maybe only, I don't know, 6 cylinders, I don't know. And then let's say this passenger engine, it really doesn't matter that this engine has kind of the less amount of it, right? Say, you know what, this engine's probably going to have, I don't know, 50 horsepower. Maybe that's a little too little, and then maybe 4 cylinders, something like that. Did I pause my chat? Whoa! Sorry, guys, I paused my chat. I totally lost you guys. I'm seeing a lot of yeses. Turtle says no, though. Uchu's probably making fun of me right now. I'm sorry. I'm sorry. You're making fun of me, aren't you? Well, this does not work. What does this do? You know what this does? This declares an engine object. This just declares one. It's the equivalent of saying my engine. That's the equivalent. That doesn't work. This engine has nothing to do with the sports engine that we're creating. This does not work. So, back to Klaus's question and what we're talking about here. This does not work, but we need a way to specify it. So we're going to call this the inline method. Say yes. The inline method. All right. So what's the syntax of that? Well, it's going to be the base class constructor with a colon. I'm sorry, I always get this mixed up. The derived class constructor, colon base class constructor, and then the params. And then the body comes afterwards, all right? This is kind of cool. Now, what does this do? The colon tells the constructor what to do before it is called. The colon tells the constructor what to do before it's called. So, all we have to do is take this out and say, you know what? This goes up here. This is where this goes. All right? This says sport engine, and when you call the constructor for the base class, I want you to call this constructor. This is the inline method. Call the param constructor. That's what we're doing, right? That's the inline. So, similarly, our trunk engine, as I said, I got it all mixed up. Please don't tell my gearhead friends that I got it all mixed up. But there you have it. All right, and that's about as far as we'll go. Now, in this like sport engine, I'm allowed to add things if I want. That's kind of what I was indicating. So a sport engine might have a bool supercharged or something. I don't know what that means. Maybe there's NOS in it or something, right? So that might have some supercharged thing. Your truck engine might have some other stuff. And your passenger engine might have some other stuff, okay? So that's why we're deriving things here. They have different functionalities, right? We might also have some function here called like void start. And we'll just say, hey, you know what? This is going to be a constant. It might not be constant elsewhere, but we're not going to alter anything. So we're just going to say, I don't know if the truck engine sounds like this, but let's kind of make it do that. What do you say? Chef asks, could we use engine int HP and int C after the derived class if we don't want the params, if you don't have the params yet? That's not possible. You're going to need to have a setter function if you want to change those values after the object has been created. So if you don't know the parameters yet, you're going to call the default constructor instead. And in fact, I should mention that. If no constructor is specified, default base constructor is called by default. All right. So hopefully that answers your question, Chef. If you don't know the parameters yet, you're out of luck there. You have to have some setter function that will change those values after the creation of the object. You need to know the parameters at that point in time. All right. So let's say everyone has this start. Say everyone has this start function here. This is going to be our sports engine. All right. And then our passenger engine, I don't know, I have to remember what my Toyota Corolla sounds like, but it might say, hey, you know, it might say vroom, something like that. Turtle asks, is using the truck engine pointer the only way to use engine as an object? You're ahead of me. I don't know where you came from, but you are thinking way down the line here. We're not going to use pointers yet. I'm going to say no. I'm going to say no. Now, this is also important. I kind of didn't talk about this. Let's say our base engine also has a void start. I'm just going to say, I'm a base engine. Thud. Maybe it just drops out of the car. All right. So I'm going to see if I catch up here. Pig says, would it be like class truck engine public? Oh, could you call the constructor when you build derived class? No, you can't. It's only specified in the constructor of the derived class. You have to remember, Pig, that these are blueprints. This is just a blueprint. This is like some magic thing in the sky that tells things how to be. When I compile this, nothing is called here. Nothing is called until I come down here and I start saying, hey, sports engine. Ugh, what am I doing? What did I mess up here? Sport engine. The moment I come down here and say sport engine SE, that's when constructors are called. All right? Only when I do this. I don't know why it's turning green. We'll give it a second, maybe if I save it. But hopefully that answers the question. No, you can't call a constructor before the class is created. These are just blueprints. There's nothing being called here. Yes, Top Wolf, you're right. Let's go ahead and throw it in there. What do you say? Just for fun. Just so you can see it. Now tell me, if I have this, what is the order of constructors called? Can anyone tell me? What is the order of the constructors? I'm going to put some couts in here. I need them. Created sport engine default. I see some questions here. I just got to focus for a little bit, but I will answer all of those in just a moment. Hopefully this is a good example. Hopefully we're following along here. I'm not going too fast. You can always slow me down if I need to, but we are chugging along full speed, aren't we? Why do I keep doing that? All right. Do we still use the dot operator to access things in public classes from main? Yes. Public members, yes. Big, big, then truck, then engine. Nope. It goes engine, then truck, then big truck. It's like the pyramid, right? It's like the pyramid. So the question was, if I come down here, why is this not doing that? I've messed something up here, guys. I've messed something up. If I come down here and I declare a big truck engine, this is going to call the engine first. And then it calls the truck engine. And then it calls the big truck engine. That's the order of the constructors. That is the order of the constructors. Maybe it doesn't like this for some reason. We'll come back to it. But I've got everything here, it looks like. Yeah, I did say constructor. All right. So, let's just kind of talk about real quick what I have here before we run this. We have an engine class. Every engine has horsepower and cylinders. Every engine has maybe some constructors here, in which a default engine has no power, and the parameter engine will kind of introduce some power here. Now every engine can start. Now this one is just a base engine. It's going to have no power really. It says I'm a base engine, so I'm just going to make the thud when I fall out of the car onto the asphalt. Okay? But sports engines say, you know what? I have some parameters here, and I make this noise when I start. Maybe I'm also supercharged. Truck engines say I have this much power, and I make this sound when I start. Passenger engines have less power, and they make this sound when they start. And finally, we have this super special engine here, which was a great suggestion from Top Wolf. We have a big truck engine. And this one is a truck engine, but it's also a regular engine. So this thing is going to have maybe some huge power here. And if we're going to have some huge power, we're probably going to need to specify another constructor. Tell me if I'm getting too far away from you here. In which I'm going to call this constructor again. But this time I'm going to pass in the horsepower and the cylinder. This is going to be the cout created truck engine parameter. All right. So now we have two constructors. We have a default, which will just pass these values in, and we have a parameter one. So the big truck engine can use this one. And so if we come down here, let's say, hey, I want you to call the big truck, the truck engine located at maybe, you know what, you've got 1,000 horsepower. I don't even know if that's a thing. Maybe it has 8 cylinders. Are we having some lag? Did it just start though? Hopefully it clears up. I'm not seeing a huge issue here. All right. So let's kind of just run some code here and let's talk about what's going on. Now, before we go through this, notice that, say we're going to have, I don't know, we'll do some lines here. Thanks for letting me know about that. So let's say we declare just a regular engine, E1, say down here, and then we're going to say E1.start. And we're just going to do this for every single engine. So this will be our sports engine. This will be our truck engine. This will be our passenger engine. This will be our big truck engine. All right. So that's engine E1. This is sport engine. Say E2. This is going to be truck engine E3. This is going to be pass engine E4. Then we're going to have big truck engine E5. Okay. Now, here's the thing. Notice that all of these have this start function. What might you call this? What thing did we have this semester that looks similar to this? I taught something earlier this semester that looks somewhat similar to this, but it's not quite the same. What might we call this here? They're all engines, and weirdly enough, well, I won't get into that yet, but do you have any ideas? If you think about it, this is public here. This is public function. So in some sense, this function is accessible by the sports engine. And Klaus, you're right. I would call it function overloading. It looks a little bit similar to that. So what I'm talking about, we might be a little bit lost, I understand, but what I'm talking about is there's a difference here between the, let's talk about it this way. There's a difference here between the engine start and the sport engine start. Did you know you could do that? I think it'll work this way. I don't know. We'll see if it'll compile. I think it should work this way, but we'll see. The engine has its own start function. This is the one that makes the thud sound. And this one has its own function, and it makes the vroom sound, right? The vroom sound. So it kind of looks a little bit like function overloading. But we're not calling it that. When it comes to inheritance, we call it function overriding. Function override. How about that? This is when a derived class and base class contain a function with the same name and same parameter list. All right? So that's what a function override is. So in this sense, in our kind of example here, this start here is the function override. This is overriding not only, this one's even kind of crazier. Look at this. We can call start from the big truck engine. Now we have to use the scope resolution operator here to specify which scope we're talking about. We can call the truck engine. And this is when things start to really get confusing. As you can see, some of you, as was just said, are probably a little bit lost, but I hope that you're kind of understanding what's happening here. In that a big truck engine is a truck engine, and a truck engine is also an engine. So they all have their own start functions. Mail asks, what's the difference between the double colon and the single colon? The double colon is the scope resolution operator. We've been using that since kind of last week. The scope resolution operator is used to resolve our scope. Where are we looking? Are we looking inside of the class? If so, which class are we looking inside? The colon is just a colon. It's like a syntax thing. I wouldn't even call this an operator. This is just required in inheritance. This is just what we use. It's just a colon. Yeah, you could say, well, it's an inheritance. It's the inheritance colon. Yeah. Well, I'd be careful with that, Turtle. The scope resolution operator is also used for classes, but to specify what thing inside of the class we're talking about. So let's talk about this here. Let's just run this code and let's kind of walk through it just a little bit to see if I can help clear up some stuff here. We're kind of coming up here on the end of class anyway, so let's just see if I can wrap some things up here. For the most part, we're going to finish the notes, and you can get started on the assignment if you really want to practice. But we'll spend some more time on Thursday, just a little bit more time to kind of figure this stuff out. I also want to add I want to add cars and stuff. Now, let's see here. I probably messed some stuff up. I'm just kind of looking at it, and I think I wanted to make this like raw or something like that. All right. I just kind of want to specify the difference there. All right. Let's look at the code. Let's call. Okay. I like that. The colon is the inheritance operator. I like that. Let's call it the inheritance operator. The other one is the scope resolution operator. In this sense, we'll call this the inheritance operator. We use it to specify an inheritance method We also use it to specify which constructor we want to call. So let's do some examples here. Where's my code? Here's my code. So let me see. I think we can see it. There's going to be a little bit of cutoff, but that's okay. So the first thing we did in main was we declared engine E1 here. So you notice that we created a default engine, right? That's what happened here. We created a default engine. And then we said start. It says, well, I'm the base engine, so I'm going to make this thud sound. The next thing we created was a sports engine, right? Where is that? Here it is. So you notice what happened here. First, we created a default, or not a default engine, but we created a base class engine. Created engine param. Where does that message print from? Well, it prints from here. And how did we know to call that constructor? By doing this specification here. This is our inline method. We're going to say, hey, call that, okay? Call that. And then we created the sports engine, right? So here's the remainder of the constructor. First, it called the base class constructor. We specified it to be the parameter. And then it continues on with whatever's in here. So then we created a sports engine and we started it. And notice that we called this start. We say this makes a vroom sound. Similarly with our engine, right? We created a truck engine here. Same thing happened. We called a constructor from the base class. And then we called the constructor from the derived class. Then we called start and we say this one makes the this sound here. Similarly with the passenger engine, same thing. And then look at this big one down here. This is the important one, right? We create a big truck engine. What happened? The engine was called. The truck engine parameter constructor was called. Look at this one. Notice we created this additional constructor so that we could control these parameters here. You can't even see what I'm highlighting, but these ones here. So that we can control them to say, you know what? This big truck engine has more power than the regular truck engine. And so that calls the truck engine parameter constructor, and it calls the base class engine parameter constructor. And it makes this big scary sound with the RAR inside of it. So since we're running out of time here, I would definitely recommend downloading this code. I think you got to download this code and mess with it. Now, this assignment, I'll talk just a little bit about it with our remaining time, all right? Next class, I'm going to do a vehicle thing, and we'll kind of wrap this up, okay? But that's pretty much all we have left. If I'm going to add anything here, I'm going to say... Yeah, I'm just going to add. I already talked about these things, so I'll add it in the notes. It is pretty interesting. So let me just talk about the assignment. Now, I'm not going to go over it yet. You're welcome to do that, and I might make a video. Do you guys like the videos? Is that helpful at all? I know some of the questions I get from the students on the last day that the assignment's due tells me that they didn't watch the assignment video, which kind of bugs me. So if you're going to get an assignment video, please watch it, because I do answer a lot of the questions that you guys have. Okay. At least you guys watch them. So just briefly, with our 2 minutes left, this is what we're doing. Yes, I did rip off of Pokemon. I said it here. We're going to define a player class and then 3 derived classes. All right? 3 derived classes. We're going to have a red class, a blue class, and a green class. If you want to think about these in gamer terms, that might be a warrior, that might be a mage, and that might be a ranger. Okay? So you're going to declare a player class, which has all the base stuff. This player class is huge. Look at it. Where is it? Where's the play? There it is. It's pretty big. This is my type of UML, okay? It's a little bit different than the one you saw before. Right, there's no plus or minus. I'm actually just telling you what they are, what type it is. Is it constant? Is it static? What's its type? What name does it have? And what its parameters are. In this case, not applicable means that variables don't take parameters. In the case that it's empty, then there's just no parameters provided, okay? So you're going to fill out this big player class, and this is where most of your work goes. And then you're going to derive these tiny little classes, all right? And they differ very slightly. They differ in these do damage functions, and they differ in their constructors. But this is all the inheritance that you'll do. There's also a little bit of composition in which each character has a weapon slot. They might have a staff, a sword, a bow, or some fists, okay? So there's a little bit of stuff going on here, too. Cade, if it says NA, that means it's not applicable. A variable can't take parameters, so there's no point to even have that slot, you know? A constructor can't be constant or static or have a type, so it's not applicable. If it's empty, that just means it doesn't take parameters. It means there's no parameters, so they're not the same. NA means you can't physically do it and compile it. But for this one, it just means it doesn't have any. Klaus, you will do header and implementation files for this assignment. Here they are. I tell you how to do them. Even down here, I kind of tell you, let's see, how to include them, and I tell you how to compile them. All right. So just to practice, try making these classes, and then I didn't give you a main. Yeah, chef, const expression is gone. You only use const, okay? You're only going to use constant. Const expression has been eliminated. All right? We may talk about that, but it's not important for this class, in my opinion. All right? So, kind of declare these, and I didn't give you a main. All right? I'll talk about this in a video, but define your own main function. And just declare a red player, and try to call those functions. And that is what's going to teach you how this stuff works. I can code in front of you all day, but as mentioned, we lose viewers every day. I put people to sleep. This stuff gets hard just to watch. You got to do it yourself. So this assignment is designed that way, in that define your classes, and then in main, go define your own stuff. Now, the code grade has its own main, all right? So you don't have to submit your main file, but it's completely on you to test your own classes. So when I get some time, I'll make a video for this, hopefully today. All right. But we will continue on with a little bit of inheritance next class, just to kind of tie up some loose ends. But I did cover everything today that you need to know for the assignment, okay? So it'll be in the notes. In this example, it's all going to work, okay? So I hope that you had fun. Thanks for coming to class today. I know it was probably a little crazy, but we're just getting caught up here. Ask me questions if you need. I'll have office hours in 13 or so minutes. And I hope you guys have a great day. I will see you guys next time. Top Wolf, I'll see you later. Have a great day. Fuzzy, have a good day. I'll hydrate. Yang, you're welcome. Synthos, you're welcome. Cade, you have a good one. Kane, have a great day. CS202 student. Dawn, CS202 student, I don't think so. I did stop the auto test today and rerun it, so I'll double check that. Pig, you're welcome. Oyman, you're welcome. Giovanni, you're welcome. CS202 student, you're welcome. Turbo, you're welcome. May I'll check memes. Cade, yeah, okay, I'll look into that. I probably made that mistake then. YCS, you're welcome. Okay, I'll change them. I'll change them back. I made a complete huge mistake there. All right, I'll change them all back. Sorry. I'll make an announcement. I'll see you guys next time.